For note packet 10, we're going to start by talking about finding intercepts algebraically. So there's really basically only two steps that you're going to have to do because there's two intercepts that you're looking for. To find the x-intercept, the place where that line would cross the x-axis, you're going to have to plug in 0 for y in the equation and then find the x. The same thing if you're looking for the y-intercept, you plug in 0 for x and solve for y. So basically what I usually do with this is I usually will divide my workspace into two different sections, so that one section I'm looking for the x-intercept and the other section I'm looking for the y-intercept. So here's my equation for the first example. To find the x-intercept, I have to plug in 0 for y. As unnatural as this looks, I'm trying to get x alone, so I'm going to start by taking 2 away from both sides and then dividing both sides by -10. So x is 2/10, or if I were to simplify that, it would be 1/5. This intercept, even though it's not a whole number, still exists because we plugged in 0 for y. Our ordered pair is going to have 0 in the y spot and our answer in the x spot. So there's the x-intercept. The y-intercept, algebraically, we would need to plug in 0 for x. Now, because in the past we have already been trained to find the y-intercept just by looking at a linear equation, you should have probably just spotted this right off the bat without doing the algebra, but even if you still needed to show your work or something along those lines, you would know the process. So since we plugged in 0 for x, I'm going to plug in 0 for the ordered pair in the x spot, and my y coordinate is going to be 2. I notice a lot of times when people are asked to find the intercepts, usually what they do is they just find one intercept because they feel like they've done enough work and don't realize that they have to find the second one also. Here's another equation. This one, a linear equation, is not in slope-intercept form. So I can't just look at this and interpret what the y-intercept is. I'm going to start by finding the x-intercept by plugging in 0 for y. If I want to get x alone, I have to multiply both sides by the denominator of the fraction that's next to it. Let's just do this real quick. So x is going to be -12. Again, -12 is the x-coordinate because we plugged in 0 for y. 0 is the y-coordinate. If we do this again, this time we're looking for the y-intercept. We plug in 0 for x. And solve for y. So y is 6. Because we plugged in 0 for x, we're going to have 0 as our x-coordinate, 6 is our y-coordinate. One thing I've noticed with problems that you might see on my math lab that are asking you to graph by finding the intercepts, the program itself doesn't really know how you found the y and x and y intercept, but if they ask you to graph by finding the intercepts, basically they're asking you to graph the 2 points that are the intercepts. So if you graphed a line and the line is correct, but you used points that were not both the intercepts, it will mark you wrong. So if you ever see a question on my math lab that's asking you to find a graph using the intercepts, make sure that the 2 points that you plot are the intercept points. So there's a lot of different methods that we have for finding linear equations. I want you to think of this like you're being given clues, and you have to use those clues to find the equation of a line. Anytime you have to find the equation of a line, remember that it should always be in slope-intercept form, and all you're doing really is trying to find two numbers, the number that represents the slope and the number that represents the y-intercept. The first thing I always do is I look at both of the ordered pairs that I'm giving to see if any of these right off the bat already is the y-intercept. You'll know because if it's the y-intercept, there will be a 0 in the x spot. So in this case, we do have a y-intercept. We know that 4 is going to be plugged in for the b. We do not have a slope. If you remember back a few of our note packets, we always have the ability to find the average rate of change if we use delta y over delta x. So I'm going to write out my formula y1 minus y2 over x1 minus x2. I'm going to make one of these my number 1 and one of these my number 2 ordered pairs. I'll write all the things that are built into the formula. Y1 is 4, Y2 is 18, X1 is 0, X2 is 7. 4 take away 18 is negative 14. 0 take away 7 is negative 7. That simplifies to positive 2. That is going to be substituted in for the slope. So the equation of this line is y equals 2x plus 4. The next example, they actually tell us this is the y-intercept, and they tell us this is the x-intercept, and we have to find the equation of the line. The number that you're going to be substituting in for b is negative 2. In order to find the slope, we're going to use the handy-dandy formula again. My y1 is negative 2, my y2 is 0, my x1 is 0, my x2 is 5. That gives me negative 2 over negative 5, or in other words, 2/5. This is going to be plugged in for the slope. So y equals 2 over 5x minus 2. Take a moment and do C. You'll pause the video and then come back and see if you did it properly. Okay, so for C, you are again just kind of given the y-intercept at 6. So in my equation, I know that B is going to be 6 using delta y over delta x. I have a y1 of 6, a y2 of 1, an x1 of 0, an x2 of 2. 6 minus 1 is 5. 0 take away 2 is negative 2. My slope is negative 5 over 2. I'm plugging that in, leaving it improper, and there is the answer. Another method or formula that you can use when you're trying to find the equation of a line is this formula that we call the point slope formula. The reason that we call it that is because all you need in order to find the equation of a line is one point and the slope. And we have a handy dandy formula that you can use to figure out what the equation of the line is. The first question that I have, A, find the equation of a line that goes through 3, 4, and 2, negative 2. Notice that neither of these are the y-intercept, so now we need to use the delta y over delta x formula to find the slope. I'm going to say my y1 is 4, my y2 is negative 2, my x1 is 3, my x2 is 2. This gives me 6 over 1 for a slope, so now I have a slope and I have at least 1 point. Actually, I have 2 points, but I'm just going to use one of them. I'm going to use this one, not for any reason, but it doesn't matter which point you use. You're going to get the same answer either way. So I'm going to say y minus 4 comes from my y coordinate, equals 6 times x minus 3. 3 is my x coordinate. Distribute. And then I'm going to finish solving the equation by adding 4 to both sides. So I have y equals 6x minus 14. It's a really good formula because really it's all in one little package to end up having the equation of the line. The next one, you actually do have the y-intercept 0, 0. So I'm just going to find the slope, which is 0 minus 9 over 0 minus 3. Negative 9 over negative 3 is 3. So I have y minus, I'm actually going to use this point right here to plug into my formula. Y minus 0 equals 3 times x minus 0. That will give me y equals 3x. Go ahead and try the third example and then come back and go over it with me See if you've kind of grasped this concept. Okay, so we're going to start by finding our slope. My y1 is going to be -2, my y2 is 8, my x1 is -6, my x2 is -5. That gives me -10 over -1, which is +10. Using my formula, I am going to plug in the second one this time. Y minus 8 equals 10 times x minus -5. While solving for this, two negatives next to each other with nothing in between is positive. Distribute and then add 8 to both sides to get 10x plus 58. The next page, we're just going to review again some special cases. Even though this says space cases, it means special cases, of the vertical and the horizontal line. We went through this with the last note packet, but we just want to talk about it one more time. The slope of a vertical line is undefined. Every point on a vertical line has the same x coordinate. When graphing a vertical line, the equation will start with x equals, and then you have to find where it pierces the x-axis, and in this case, it is 5. The slope of a horizontal line is 0, 0 slope. Every point on a horizontal line has the same y-coordinate. When graphing a horizontal line, the equation will start with y equals, because it pierces the y-axis. In this case, it pierces the y-axis at 6. Some of the stuff I was talking about in the past when we were talking about whether or not something is a function, just to go over that again, a function has all unique x values. If you have a graph of a function, we have this thing that we call the vertical line test, which basically states that if you have a graph and you run a vertical line along it, if it only touches that graph at one spot at a time the whole way, then it is a function. Notice the first example here, if you ran a vertical line from left to right, it always only touches it once, so this is a function. The next one, the vertical line, when you run it along, it always hits it just one spot at a time, so this is a function. This last example, you are fine until you get to this point here, where you end up hitting the graph 1, 2, 3 times at the same time. This is not a function. One x value can return 3 different outputs, and so that would mean that the x values are not unique. Let's look at some of the questions that go with this. In order to be a function, a vertical line can cross a graph one time. That's it. There is a vertical line that crosses this graph twice. This means that the graph is not a function. Hits at 2 spots at the same time. Each vertical line crosses the graph only once, so this means that this graph is a function. They do 3 different examples of vertical lines right there, showing it only touches the graph one spot at a time. Is this graph a function? This is not a function. My vertical line can hit this twice at the same time. The last one, is this a function? Yes, almost every line is a function unless it is a vertical line. The last one, this is an exponential function. Even though this is going to get really, really steep, it will never have a spot where a vertical line touches it twice, so we're going to say yes. We're going to talk about solving systems of linear equations. In the math world context, a system means more than one. More than one. When solving a system, you can have 3 possible outcomes. I'm going to demonstrate these using a visual method of linear equations that are graphed. So the one outcome that happens a majority of the time is that you graph your 2 lines, 2 is more than 1, and you have 1 intersection point, and this means that you have 1 solution. Another thing that can happen is that you graph these lines and they end up being parallel. If they're parallel lines and they never intersect, so that's what parallel means, then that means you have no solution. The last example, you graph your line, then you graph your second line, and they end up being the same line. This can happen, and if it does happen, that means that you have infinitely many solutions because they are intersecting everywhere. Another way of saying this is saying all real numbers. Since there are so many methods for solving a system, I only put like 4 of them down here. We're going to actually be looking at substitution and the graphing method on these notes. Just remember that the goal of solving a system is to find a solution which comes in the form of an ordered pair that fits both equations simultaneously. So here is a system. The system is 2 different linear equations, and we're trying to find a solution that not only works in the first one and makes it a true statement, but it also works in the second one at the same time. Now we're going to use the substitution method, which basically means we're setting 2 things that are equal to each other. I don't know if that makes any sense, but hopefully it does. For instance, you probably would agree with me that y is equal to y. Well, we have y is equal to this, 3x minus 10. So we're going to substitute that in for this y. And we have y is equal to 5x plus 14. So we're going to substitute that in for this y. So we would have 3x minus 10 equals 5x plus 14. Going through all of the steps that I would go through to solve this equation, negative 24 equals negative 2x. X is equal to 12. I found the first part of my solution, 12. I now need to use 12 to find the y-intercept, or not the y-intercept, the y-coordinate of my solution. So I can use either one of my original equations. I'm just going to use the first one, y equals 3x minus 10, and I'm going to substitute 12 in for x. Y equals 26. Once I get to that point where I have that ordered pair, I have a value for x and a value for y that not only makes the first linear equation true, but also makes the second linear equation true, then I know that I have finished the problem. Go ahead and take a moment and do B, and then come back and compare your answer to mine. Okay, so I'm setting negative 2m plus 9 equal to 3m minus 11. I'm going to take away 3m from both sides. And then I'm going to take away 9 from both sides. And divide both sides by negative 5. So my m is 4. I'm going to use one of my original equations to plug in 4 for m. And this is how I find the n. N is 1. Solved. Now we're going to take a graphic approach to solving systems, looking at this very first one. So this is one of those times where it's kind of important to make sure you have very accurate points and a very accurate line, because we're looking for the intersection of 2 lines to find what is the solution to this system. So this first one, my y-intercept is 3. My slope is 5 over 3 with a negative either on the top or the bottom. I'm going to actually put the negative with the top. So I'm going to rise negative 5 and run positive 3. Here's going to be my first line. See if I can use a straight edge this time to get a line that looks better than in the past. There we go. I'm going to change the color for my second one. And my second one My y-intercept is -3. My slope is 1/3, rise 1, run 3. Even though I already see where these are going to intersect, I'm still going to finish drawing my lines. The intersection point happens at 3, -2. That is the solution. This next one is using my special cases situation for the first equation, which is y equals -1. That means that this is going to pierce the y-axis at -1, so my line must be a zero slope line. It's not very straight, but that's fine. The next one, 4, is my y-intercept. My slope is -5/2. I'm going to rise -5, run +2. Draw my line. My solution is 2, -1. Okay. Look at the next one. For this one, my first equation has a y-intercept of +2 and a slope of -2, so this is where I'm going. And I'm going to go ahead and draw my line and arrows. I'll change my color again. Next one has a slope, a y-intercept of -2, a slope of -2. After doing all of those points and drawing the line, and hopefully this is not a surprise, these are parallel lines that never intersect, and if they never intersect, that means we have no solution. No such solution exists that can make both of those equal at the same time. Go ahead and try the last one, pause, and come back, see if you got the right answer. This next one has a solution of 4, -3. The next page we're looking at inequalities. If you don't remember inequalities, that is anything that has the less than, greater than, less than or equal to, greater than or equal to symbol. Really, we're going to be looking at solving inequalities. So you just have to know two things, two rules for solving inequalities. The first one is if you multiply both sides by a negative number, flip the sign. The second rule is if you divide both sides by a negative number, flip the sign. Basically, all the steps that you have for solving inequalities are exactly the same steps that you would use for solving equations, except for those two rules. I still strongly suggest you draw a line so that whatever you do on the left side of the line, you do on the right side of the line. And also, please remember at the very end not to mistakenly put an equal symbol. So this one, if I distribute my 3, I get 3x minus 12. Distribute my 5x minus 10 minus 8. I'm also going to simplify the right-hand side, so it's 5x minus 18. And then I'm just going to go through all the steps that I would go through if I was solving this and it was an equation. Get my x on one side, get everything else on the other side, divide both sides by 2, and then that gives me 3 is greater than x. I can rewrite this if I want to with x being the start of it, as long as my sign is opening up to the proper side. So 3 being greater than x is the same thing as x is less than 3. Now, I didn't have to flip the sign at all that time because I did not multiply both sides by a negative number or divide both sides by a negative number, but depending on how you did this, you may or may not have had to do that if you did different steps than I did in different order, which is more than okay. Some examples. I'm going to do the first one with you, and then I'm going to have you do the last 3, and then come back and compare your answers. This one, 5 minus x is less than 2x minus 6 plus 5. 5 minus x is less than 2x minus 1. I simplified on the right-hand side. I'm going to take 2x away from both sides. So I have 5 minus 3x is less than negative 1. Subtract 5 from both sides. Negative 3x is less than negative 6. Divide both sides by negative 3. I am dividing by a negative. That means I have to flip the sign. X is greater than 2. Take a moment, pause the video, do BCD. I'm going to put the answers up so when you're done you can compare them. I posted on here the answers. B being x is greater than or equal to 8. C is x is greater than or equal to negative 2/5. D is x is less than 10/3. The only one that I really anticipate that was probably really challenging was C. So that one I'm going to show you how I came up with that solution. Lots of different ways that you could have done this. For instance, right away, if we felt like not comfortable with the fact that we have one that is a fraction, I've always told you if you have a fraction to multiply both sides by its denominator, I can do that right off the bat if I want to. If I distribute the 2 to both of these terms, it would cancel out the 2 on the first term, and then 2 times 1 is 2. If I distribute the 2 on the other side, now this is something beautiful. So I can subtract x if I choose to do it this way. I can subtract 4. And then I can divide both sides by 5. And then I can write it out. And I can write it out either one of these ways as long as the symbol is opened up to the proper piece. So that's the last example.